Hello, welcome to SM Tech World. Today we are going to solve the LeetCode problem number 1290. So today's problem name is convert binary number in a linked list to integer. Okay, so let's try to understand the problem statement first. So what they are saying here, they are saying that we will be given one linked list. So you can see it's a linked list, and each linked list node will contain one value. That will be a binary value. That means it will be either 0 or 1. Okay, and we need to traverse the whole linked list, and we need to keep capturing those binary numbers, and we need to, at the end, we need to convert that binary number to a decimal number, and we need to return the same. Okay, so you can see this also here, right? It's 101. So if you convert 101 to decimal number, it will be 5. Okay, so basically it is the base 10 of binary number. Okay, so basically this is the problem statement. You can check out the other example also. Then those are also pretty self-explanatory. So if your head is 0, you need to return 0. If it is 1, it will return only 1. Okay, and you can check other examples also. Okay, so this is the problem statement. Okay, so let's try to identify solution for the same. So basically we are going to see two different approach to solve this problem. So let's try to see those approach at first. So our first target will be, we need to traverse the list. Okay, so basically we need to use linked list traversal. So we will traverse each and every linked list, and we will keep adding this number. Okay, so basically what we can do, we can take one number. Initially let us declare as 0. Now whenever I will find one value, we will multiply with that into 2, right? Whatever my number value plus my current value. Okay, so if you do that, then we can just return this decimal number at the end. So that's the normal ways to convert a binary number to a decimal number, right? So like this, right? So it should be 2 into 0, then 2 to the power 1, then 2 to the power 2, right? So this will give us the actual decimal number. Okay, so let's try to write the code using this approach first. So what we will do here, we will take one number, so and we will declare that as 0 only initially, and let's try to add some edge cases also for safer side. So we will check if my head is equals to null, then we don't need to do anything. We can return number or 0 from here only. Okay, and if not, then we need to traverse the linked list. So for traverse the linked list, what we can do, we will, so linked list has next node, right? So we will keep traversing till my next is equals to not equals to null, right? So whenever at linked list means the last node will point to null. So whenever I see that my current node is reference is null, then that means we reach to the linked list end. Okay, so let's write the same logic. So it should be head should be not equals to null, and what we will do, we will use the same simple formula, right? So our earlier number value, it should be number into 2. So whenever I will find one value, I am going to multiply that the existing value with 2, and then we are going to add the same value at the end. Okay, so it should be head dot file. Okay, and after that we need to move forward our counter, right, or pointer, linked list pointer rather. So head should be head dot next, and at the end we can return number. Okay, so what we are doing here, we are starting from here, then we pick 1, we will add that in our number value, then we pick 1, then this we will pick 1, and at the end we are returning the number. Okay, so this is the basic way, or one of the way to solve the problem. So let's try to run the same and check whether it's accepted or not. Yeah, I think it's giving us expected answer for the first test cases. Let's try to quickly submit the same also and check. Okay, I think our solution is also accepted, and here if you analyze the time and space complexity here, so time complexity is obviously order of n. N is the number of node in the linked list. Basically we are iterating through each and every node, so obviously time complexity will be order of n. But in case of space complexity, we are using constant space here, so it will be order of 1. Okay, so this is the approach 1. Okay, so now let's try to see the second approach. Okay, so we are just using here the normal arithmetic formula, right? We are just multiplying it, the existing value with 2, then we are keep adding those value, right? So instead of this, we can use the bit manipulation, right? So let's try to see what is bit manipulation. Bit manipulation, what we will do, so we will again take same number, one variable called number, and it will be 0, right, initially. So 0 means, so you know that, right? If you convert that 0 to binary number, it will be 32 times 0, right? Okay. Now what we will do, we will keep starting from the first point, right? I will find that my first value is 1. So what we will do, this was my earlier value, right? I am going to do the bit shifting by 1. That means, so suppose it is look like this. Let's consider a smaller example. It will 0 0 0 and I will shift 1 bit in the left. So that means this will come in the second position, this will come in the third position, right? And the rightmost position will be filled by 0. Okay. So for the first line it will remain same, or first value it will remain same, and after doing the bit shifting we are going to just perform the OR operation with my current value, right? So I can see my current value is 1, so we will do OR operation. So it will be look like 0 0 and 1. So after doing OR it will be look like this, right? 0 0 1. Okay. Now my current number is contains this value, right? Number is equals to 0 0 1. Now I will come here, I will pick the second number, right? Now it is 0. So again I will do the left bit shifting by 1 position, right? So after shifting it will look like this. 1 will come in the second position and this 0 will come here, and remaining rightmost bit will be filled with 0. Okay. Now again we will do OR with my current value. Current value is 0 0 0. So it will remain same. So it will remain 0 1 0. Now again I will come here and my current number is 1 and my currently in number variable we have 0 1 0. Again we will do bit shifting. So after bit shifting it will look like this 1 0 and rightmost bit will be 0. And again we will perform OR operation with my current value. Current value is 1, right? So it will look like this 0 0 1, and if you do this OR again it will be 1 0 1, and we can at the end we can return the same, right? So using this approach we can easily solve it by doing bit manipulation. Okay. So let's see this and let's try to write the code for the same. So let's take one variable. Let's take one variable named temp, and initially let's declare it as 0 only. Now again we are going to run same while loop, and it will run head till same logic, head not equals to null, and again we will do the bit shifting, right? So we will update my temp like this. So at first we are going to shift the same. So let's shift it by 1. Temp should be shifted by 1 position, and we are going to do OR operation. So we are going to do bitwise OR, right? So it will be single. Okay, single OR, and now we will do the OR with my current value, right? So that means head dot val. Okay, and then we can keep moving our linked list pointer. Okay, so it should be head dot equals to head dot next, and at the end we can return the same. Okay, so it should be temp. Okay, so let's quickly comment out the earlier approach and let's try to run the second approach quickly. Okay, and let's try to compile the same. Okay, you can see the second approach is also accepted. Let's quickly submit the same and see. Okay, I think our second solution is also accepted, and again in this case also the time complexity is order of n, since we are going to each and every node, and the space complexity is order of 1 since we are using only one constant variable, that is temp, irrespective of my input size or node number of nodes. Okay, I think that's pretty much for this video. If you like this video, please hit the like button and subscribe to our channel. Thanks for watching. Bye bye.